So, during the break in between videos, I got hungry. Rice Krispie treat and a Pepsi. It's a good combo, right? Yeah. Sugar, caffeine, it's all good. It doesn't matter what time of day it is, right? Okay, so we're continuing our use of the standard normal distribution to find the areas under a curve, specifically the standard normal curve. And we left off with one that had a positive z-value and a negative z-value when we were finding the area between them. So let's look at another scenario. Whoop, a little too high up in the air there. Find the area between. For now, we're going to be using some of the same wording over and over. You're going to find that's going to change, though. That's not going to remain the same. Here we want to use two positive z-values. We're going to use z equals 1.08 and z equals 2.2, both of which lie to the right of the mean. The same general setup would occur if we pick two values to the left of the mean, two negative values. Okay, so let's sketch it. Now our mean is 0. Now be cautious, 1.08 should be closer to 0 than 2.2 is. So 1.08 closer to the mean, 2.2 further away from the mean. And we're finding the area between them, so there's our shaded region. Now, in terms of this shaded region, when we use the table, if I was to look up 1.08 in the table, it's going to give me the area here between 0 and 1.08. So let's look that up. 1.08 gives me an area of 0.3599. Now, when we go to look up 2.2, remember the area in the table is always between 0 and that value. So what we're getting in this case is this entire area from 0 all the way over to 2.2, as if we were to shade all of that. I'm not going to do that here because it's not the desired answer, like final answer that I want. So if I look up 2.2, 2.20, 0.4861. So if the 0.4861 represents all of this area, from 0 all the way over to 2.2, but I only want this portion of it, then the way that I'm going to find that particular portion is to take this 0.4861 and subtract from it 0.3599. And that's going to give me what's left, which remains here in the shaded region. So 0.4861 minus 0.3599. Let's see, we end up with 2, 6, 2, 1. 0.1262. And that's the area between two positive values. If it made them both negative, the process would remain the same because of that symmetric nature on either side of the mean. So that's not going to change at all, positive or negative. And remember, your area stays positive. All right. So we're not going to do two negative values. Let's move instead to find the area to the right of C equals 1.45. Okay, so here again, start with our sketch. There's my 0 mark. 1.45, of course, lies to the right of the mean. And I want the area to the right of it, which means I'm going to shade out here in the tail. Keeping in mind that when I look up 1.45, it gives me the area between 0 and 1.45. So if we look up 1.45 on our table, we end up with 0.4265. So this area between 0 and 1.45 is 0.4265. Now you'll recall that we said before, that the mean divides the values or the area in half. Half of the area is on one side, half the area is on the other side. So this entire right side to the right of 0 is 0.5. If I don't want to include this area of 0.4265, but I do want the area in the tail, then I take that half and subtract from it 0.4265. And that's going to give me the amount of area that lies in the tail on the right side. Keep in mind that a similar question in this case would say find the area to the left of a negative value, so that it pushes the area into the tail, not nearest the mean. All right, so in this case, when we subtract, we end up with 0.0735 for that area. There will be times that we start to think of these decimals as percentages. You'll see that a little later, but it's not quite time for that yet. All right, continuing on kind of the realm of to the right of, to the left of. Let's look at another possible example that we could have. Find the area to the left of z equals 1.45. So we're going to use that same z-score that we did in the last problem, but we're using it differently. Okay, so to the left of that value. So start with your sketch. There's our mean straight down the middle. 1.45 lies to the right of it. And now I want to shade to the left of that value, keeping in mind there is no lower limit. It doesn't say to shade between that value and 0. It says go to the left of it. So we continue to the left. Now, looking at that, I see two things. I know that from the behavior of this distribution, that this half of the graph totals 0.5 in area, because the whole thing is 1, to the left is half of that. I know also that if I were to look up 1.45 in the table, that it's going to give me the area between 0 and 1.45. So using that same z, or that area that we got on the last one, 0.4265, now we can see that there's no subtraction necessary. We want the total area, which means I'm going to take this value of 0.5 and add to it 0.4265. So now we're looking at a sum. So the total area in this case, 0.9265. So 92.65% of the data lies to the left of 1.45 for a z-score. Similar question would say, given a negative z-score, find the area to the right of it. Here you're adding 0.5 because of the fact that it includes half of the graph. The entire left side or the entire right side. All right, so that gives us another possibility. Now, the last possibility that we need to look at is finding the area in both tails. We've already talked about how to find the area of a single tail. We did that here the previous problem that we just did. So another example could be finding the area of a tail on the left and a tail on the right, where we have both. So here it will look something like find the area to the right of z equals 1.9 and to the left of z equals negative 2.18. We could also say greater than 1.9 and less than negative 2.18, keeping in mind that those greater than, less than words can come into play as well. There are also other ways that we can write these using inequality statements, like with a greater than or less than symbol. So in this case, z of 1.9 is going to be over here to the right, and we want to shade to the right of that value. So there's the tail like what we looked at before. Well, we've already determined that to find the area of that tail, we take the area here, which is given in the table, between 0 and 1.9, and then subtract that from a half. Likewise, on the left, we have a z-score of negative 2.18, and we want to go to the left of that. So there again, the same process applies, it's just a different value that we're looking up in the table. Okay, so we go to the table. I'm going to use this 1.9 first, and that tells me the area is 0.4713. I want to subtract that value from 0.5, so 0.5 minus 0.4713. Fill in those zeros if we need to. Gives me an area of 0.0287. Now we'll repeat the process on the other side. So negative 2.18, looking up 2.18, we end up with 0.4854. 0.4854. So the area of this tail will be 0.5 minus 0.4854. There again, we can fill in those trailing zeros if we need to. So the difference in this case, 0.146. Now, if I want the area of both, I need this area and that area, then I add them together. So 0.0146 plus 0.0287, and simply add. 0.0433 becomes our area in that case. And that takes care of all the possible scenarios for which you're going to be asked to find areas. A couple of things to mention. The word between is used frequently. You'll also find that the book uses the middle 50%, meaning 25% lies to the left of the mean and 25% lies to the right of the mean. So some of those words are going to come into play. Nothing that you've never heard before. Nothing that you can't discern what it means through just your basic knowledge of English terms. So in this case, this is what you would need in order to find areas. In section 6.4, we'll start talking about how those can be applied to word problem scenarios. There is one more video that you need to watch for this section, and that's going to be how the explanation as to how these correlate to probabilities that we're talking about in these probability distributions. So, see you shortly. One more to go.